Hey everybody, welcome back. We're going to work on the next couple of problems here, and we've got number 4, and it gives us some information in our prompt. It says a wheelbarrow is used to lift a 200-pound load. So we have a couple pieces of information there that are going to be useful. The first is what tool are we using? We need to identify what type of lever is that, and a wheelbarrow is a second class lever, and then it says to lift a 200-pound load. So right off the bat, I know that my force resistance is 200 pounds, okay? The length from the center of the wheel, which is our fulcrum, the center of the wheel, to the center of the load is 2 feet. So that tells us that my distance resistance is 2 feet. And then it says the length from the wheel to the effort is 5. So our distance effort is 5 feet. So I've kind of gone through there and said, what are my knows? What are my need to knows? And so obviously the thing that I'm missing is my force effort. And I'm sure it's going to ask us that. So then we annotate it. So I'm going to say I've got a fulcrum and I've got a lever, okay? And we'll say that I've got a force resistance at 2 feet is 2 feet. And then we had our 200 pounds. Whoops. And then our force effort is unknown at this point. So then I can say my distance here is 2, right, to the fulcrum. And then my distance effort from there is 5 all the way out here, right? So now it says, what is the ideal mechanical advantage? Well, IMA is ideally I'm going to kill a deer, distance effort over distance resistance, and then I can just plug and chug here in my substitute and solve box. So distance effort, okay, 5 feet, divided by distance resistance is 2 feet. Well, 5 divided by 2 is 2.5, and those units, of course, cancel. And so we have no unit of measure for mechanical advantage. The next thing we have is a question that says, using our static equilibrium calculations, calculate the ideal effort force. Now, a couple of things that I want to point out here is that it says we're going to use the static equilibrium calculation. And remember, that is moment effort is equal to moment, resistance. So we rewrite that because moment is force times distance. So we'll say force times distance is equal to force times distance. On one side, we're going to have our resistance. And on the other side, we're going to have our effort, like that. Okay, so we know we're going to use that formula. And it says calculate the ideal effort force. And the key here is normally when we've been talking about forces, we've been talking about actual. But when it says ideal effort force, what it's telling you is what would the force be if there wasn't any friction? And remember, that's why we can also use that setting IMA is equal to AMA, because we're talking about just a theoretical calculation. So I could do this once again either way. And so we'll do it like this, though. So it's just a simple plug and chug. Force resistance, 200 pounds times distance resistance is 2 feet is equal to force effort, which is our X, we don't know it, times our force effort, which is 5 feet. So when I solve this, I got to isolate the X, so divide both sides by 5. Those are going to cancel. So 200 times 2 divided by 5, it gives us 80. That's what we're left with. So if you have any questions, please shoot me an email.